Okay, good morning, year 12 further mathematicians. Just going to go through the next subsection 11.5 on integration by substitution. So this subsection allows you to do allows you to change some complicated integrations into ones you've done before. So e.g. number 1, we've got to integrate x square root 2x plus 5 with respect to x. And if you try to use the methods we've been taught so far, by maybe trying to spot a pattern or using reverse chain rule or something, it would be almost impossible for you to guess something good for this. So the main problem is, if I wrote that to the power of a half, it's none of the patterns we did last time, and yeah, it's just too hard. However, we can use something called integration by substitution, which is changing this entire integral using a different letter and coming up with something which we can integrate. Now, I'm focusing on the most complicated part of this integral, which is the thing inside the square root. I'd rather just square root a single thing rather than 2x plus 5. So this substitution that I've come up with is replacing that 2x plus 5 with the letter u. So let's see what that would change to. So I'll call this integral I, and then I would be equal to integrating x square root of u instead of 2x plus 5 dx. Now the problem is I've still got other letters of x inside that integral, and I need to get rid of them all. So how can you get rid of this x and replace it with just letter u's? Well, you go back to your substitution and you make x the subject. So if you make x the subject, you would get subtract 5 and divide by 2. So u subtract 5 divided by 2. So in my integral, I can replace the letter x with u subtract 5 over 2. And now I can rewrite this in index form, u to the power of a half. Now the problem is, I'd still be integrating with respect to x, but I want to integrate with respect to u. So how can you replace the dx with a du? And there's a trick to this. You take your substitution. How can you get some dx's and du's in this substitution? It would be if you differentiated. So I can do du by dx. So this differentiate with respect to x, you just go to 2. And then this is a trick that does work. You make dx the subject. So how can you make dx the subject? Effectively times by dx and then divide by 2. So it would be dx is equal to a half du. And then replace the dx as well with a half du. And now I've got something which I can integrate. Let's see if I can do it. So firstly, you've got these halves in there, so you can write that as quarters. So I would have integrate a quarter. Now what would the brackets expand to? U times u to the power of a half is u to the power of 3 over 2. And minus 5 times u to the half is minus 5 u to the half du. And now this is something you can definitely integrate. Everything's in index form, and you can just add 1 to the power divided by the new power. So this is equal to a quarter, add 1 to the power, 5 over 2, divide by the new power, next one, add 1 to the power, it's 5 over 4 by the way, 3 over 2, divide by the new power, remember the plus c. And obviously that would simplify to, let's just do these fractions, don't want to make a mistake. So we've got a quarter divided by 5/2, which is a 10th, u to the 5/2, and then 5/4 divided by 3/2, which is 5/6, u to the 3/2 plus c. And you can potentially leave your answer like that, or if you wanted to, you can actually get an answer just with x's in there. So remember, this is the letter u, and that is a formula for u up there. If we replace every letter u with 2x plus 5, you actually get the answer in terms of x. And hopefully you'll agree that it was unlikely you were going to guess that answer from the start, so you couldn't really use the previous methods. You had to use a substitution. And the key thing in the substitution was focusing on the most complicated looking part and just replacing it with a letter. You can use any letter you like, just use the letter u. Okay, this next one, we have integrate cos x sin x brackets 1 plus sin x to the power of 3 with respect to x. And we have to use a substitution. Any ideas on what substitution you would use? Again, you want to focus on the most complicated looking bit and just replace it with a letter, and I'm going to use the letter u. Now, the obvious substitution to me would be something to the power of 3. I prefer it just to be a single letter, so I'm going to replace 1 plus sin x with the letter u. And let's see what changes. So the integral would become cos x sin x u to the power of 3 dx. But then we have some complications again. We've got x's still in there and they have to go. Now, if you look about what I have to replace, now I'm happy to replace the sin x because I could make sin x the subject, like so. But replacing cos x is a lot more difficult. However, sometimes it's not even needed at all, because these substitutions are so clever that you don't have to do anything complicated other than just make something the subject. So I'm not going to bother trying to make cos x the subject in any of this. I'm going to see what would happen if I just replace the dx. So how do you replace a dx with a du? You differentiate once. So du by dx. What does this differentiate to? Well, 1 goes to nothing, and sin x differentiates to cos x. And then I want to make dx the subject. So if I made dx the subject, what would I get? Divide by cos x, so 1 over cos x du. Now, I'm going to do all of the obvious substitutions now. So I'm going to integrate. Cos x was too difficult for me to work out, making it the subject, so I'm going to leave it as it is for now. Sin x wasn't too bad because I can make it the subject really easily. U cubed, that was the easy bit. And now dx I'm going to replace with 1 over cos x du. And this is where the simplification comes in. The complicated parts disappear, and you are just left with u minus 1 u cubed, or if you prefer u to the power of 4 subtract u cubed du. You're just integrating stuff with u's in there with respect to u, and you can definitely do this. So you add 1 to the power, divide by the new power, so a fifth, add 1 to the power, divide by the new power, so that's a quarter, plus c. Or if you have to give your answer in terms of x, it would be a fifth. Every letter u replaced with 1 plus sine x, 1 plus sine x to the power of 5, minus 1 quarter, 1 plus sine x to the power of 4 plus c. And yeah, again, there's no way anyone's going to guess what this was from the start, so you have to use this substitution. Now, I want you guys to try some questions from the textbook. So if you find page 306, exercise 11E, most of these they're going to give you the substitution, but there's a few of them where they don't. So if you try question 1 and also try question 3. Question 1 they give you the substitutions, and question 3 they don't. You have to try and come up with them yourselves. And my only piece of advice would be do the easy substitutions like I did in this, e.g. number 2. And if there's something which wasn't obvious, like replacing cos x in this substitution, just don't bother doing it. It's probably something's going to disappear later on like they did in this step there. So replace the x's with the new letter u, or whatever letter they use in the question, and then go from there. Okay, cheers.